Now that I've summarized my question and written it out in a way that I can understand, it's time to start thinking about what I have, what I need, and what I might do to get to my goal. I'm going to start by looking a little bit at our picture here. We know that we've got a ladder leaning against a wall. And what we can see right away is that these shapes, the ladder against the wall, make a triangle. So I'm going to redraw this triangle down here. There is some outside information that I'm bringing into this, things that aren't mentioned in the question. Like, for example, though it may seem simple, the fact that 3 sides, that makes a triangle. Another piece of information that I can bring in is the fact that walls are usually 90 degrees from the floor. It doesn't say that in the question, but it's fair for us to assume that that's the case here. So I know that this is a 90-degree angle. So now what I've got is not only a triangle, but a right-angle triangle. So let's think about some things we know about triangles. We know that triangles have all angles add to 180 degrees. And we may or may not need this information, but this is doing sort of what I would call looking into our mathematical toolbox. What tools and information do we have available to us that we could use? We may or may not want to, but we want to know what's available. So we know that. We also know perhaps that area equals 1/2 base times height. Specifically right-angled triangles. Well, what else do we know? Well, we know Pythagorean theorem, a squared plus b squared equals c squared. We know that this is the hypotenuse is the longest side. We may know some other things. We may know some trigonometry. We could know that sine theta equals opposite over hypotenuse, or maybe we haven't learned those yet. So try to think out all the sorts of things that you know, that you could know and you could bring in to this question from outside. Now let's look again at what we have. We know that we've got a 9-degree triangle. We know that this side down here is 9 feet. We also know that these two are related in some way. It's probably time at this point to bring in some kind of variable. And variables really just are a way of representing something that we don't know right now, so that we can talk about it and relate it to other things. A good policy that often works, not all the time, but most of the time, is to set your variables equal to the thing you're looking for. So I want to know how long the ladder is. So I'm going to say, let x equal the length of the ladder. Saying it explicitly like this lets me refer back in case I forget what x is equal to. So x is the length of the ladder. Well, I'm going to write that right here. Now I don't know anything about this side, or do I? Well, I know that it is the height on the wall, and that length of the ladder and height on the wall are consecutive integers. That means that they're numbers that come one right after the other. Is this number going to be the next number after x, or is it going to be the number before x? Well, if I think through some specific numbers, if this was 5, would this be 6? Or if this was 5, would this be 4? If I look to what I know that on a right-angled triangle, the hypotenuse is the longest side. So if this is 5, there's no way this could be 6. So this must be 4. Well, how are 5 and 4 related? Well, 4 is 1 less than 5. It's 5 minus 1. So if this is x, this side is going to be x minus 1. That takes care of this relationship, the fact that they're consecutive integers. So now I have a triangle. I know it's a right-angled triangle, and I have representations of the 3 different sides. So which piece of information here am I going to use? Well, I can look through and figure out which of these relations and bits of information have things that I need. I don't have anything to do at all with angles other than the 90-degree angles. So probably this piece of information isn't going to be much use. Additionally, there's never been any mention of area, and I can't even imagine what area would represent in this idea. Who would want the area underneath a ladder? This piece of information, well, this is a relationship between the three sides of a right-angled triangle. I have three sides of a right-angled triangle in my diagram. I would really like to solve and find out what one of them is, so it seems like this is something that I would want to use. So we try this out. A squared plus b squared equals c squared. Well, a squared and b squared, those are the two legs of the right-angled triangle. So I know that, well, 9 squared plus x minus 1 squared should equal x squared. And what I've got now is I've basically gotten through step 4, where I've analyzed what I have, what I need, and what I can bring in from outside to create some kind of a mathematical statement or a series of steps to get me to my goal. Because my goal is to find how long the ladder is, that is to find x. I now have an equation that is in terms of x that I could solve to just find x. So I'm ready to move on to step 5, which is to calculate, to actually figure out what this value is. So I can go through the process. 9 squared is 81, plus, if I expand this out, x squared minus 2x plus 1 equals x squared. Subtract x squared from both sides. These guys cancel. We have 81 plus 1, which is 82, minus 2x equals 0. 82 equals 2x, divide by 2, so we end up with x equals 41. And now I've finished the make a plan and take action phase of SRL problem solving.